All right, lesson 7. Slope as a rate of change. So this is nothing actually new in here. We're just going to talk about it in a unique way, or I don't know, maybe make an application to what we've been learning. So make it like, when do I use this in real life, or what does this mean, or why would I do this? Maybe this lesson will help you with that. So right off the bat, they say the graph shown represents the distance traveled by a car as a linear function of time. Okay, what are the two pieces? Distance and time. Understand? You have to kind of know. So this is very important that you understand context of these questions. Just like when we did domain and range, which to understand what's going on in the question, you have to understand what's going on in these. Okay? So we have a car. It's traveling. We're looking at the distance, how far it goes over time. It says complete the following to calculate the slope of the line. So if we know, we don't even need to have that little formula. We know we go y minus y over x minus x. Yeah. Every time we want to find slope. Okay, so we could go 120 minus 40. That's your y minus y. If in doubt, walk over here and put x and y on there, right? Make sure you label your points so you don't get messed up. That's a simple, silly mistake. 120 minus 40 over what? 3 minus 1. So that's 80 over 2. 120 minus 40, right? So we end up with 40. Okay. And it says the slope, this is what we're learning today. The slope represents a rate of change. A change in distance divided by change in time. Because remember, this would be 80 kilometers divided by 2 hours. So see, we end up with kilometers per hour. Pretty cool. So I know if this was where he was 40 kilometers in 1 hour, and then he was 120 in 3 hours, I can figure out that really the distance was increasing. It's a positive slope. You with me? Increasing slope at a rate of 40 kilometers per hour. Really nothing that you didn't know before, but it just puts a little bit of context to our slope. Okay, let's try again. This graph shown represents the temperature of an oven as a linear function of time. So temperature and time. Got to keep track of what we're talking about. Temperature is the y-axis, time is the x. And so we can say, okay, let's find the slope. Y minus y over x minus x, right? You understand how to find slope. Let's just review. Yeah, Miles? You with me on it? Okay, so I end up with 300 over 5. Now, what are we talking about? 300 what? Say it again?
Degrees.
Yeah, 300 degrees over 5 what? Minutes. Right, so we're talking degrees per minute. So it says the slope represents a rate of change. We should finish this off, by the way. So 300 divided by 5, we can go on down to 60. Right. And it says slope represents a rate of change in temperature divided by a change in time. So the units that are represented to do this would be degrees and minutes. So think about what we're talking about. Degrees and minutes. And it says, are we increasing or decreasing? Is our temperature increasing or decreasing? Increasing. It's a positive slope at a rate of 60 degrees per minute. Good. So nothing really rocket science involved in this. You're just adding context to your slope. 60 degrees per minute. I could write a little degree symbol in here. There. 60 degrees. Any questions? Does it seem pretty simple? Okay, good. Let's go here. How about this one? The graph shown represents the amount of fuel in a gas tank of a car as a function of the distance traveled. Okay, what are we talking about? Distance and
Number of liters in the fuel tank.
fuel. Yeah, distance and fuel, exactly. So does it make sense to you that the farther you go, the fuel decreases? It should make sense. The picture should make sense. You got it? As we go along, we're using up fuel. Fuel's going down. Okay, so find the slope. Okay, label. So I'm going to go 40 minus 50 over 120 minus 20. Did anybody go the other way already? It's okay if you did. Don't change it. Go ahead and finish. You find your slope, I'll find mine, and we'll see if they're the same thing. Same thing? It's a negative. I don't really care where the negative goes. It can go in the top, the bottom, or in the front. Doesn't matter. So it doesn't matter which way you go on the points. You should get negative 1 for 10. So what does that mean? What is 1 and what is 10? 1 is what?
1 is the fuel.
Okay, so liters. Yep. The 1 is the liters, and the 10 is the kilometers traveled. So according to this, you're using 1 liter for every 10 kilometers traveled. $10 liters per 100. Anybody know what's your fuel economy? Okay, boys. Does your fuel economy, I don't want to know miles per gallon. I want to know how many liters now per 100, because that's the way they do now.
14.
What is 14 liters per 100? What vehicle are you driving? A pickup. Yeah.
My cousin's deleted diesel gets like 9. It's a dually 3500. Yeah.
And what is it?
It's just like a 2015 Dodge Dually 3500. Yeah.
Dodge Dually, and you're trying to tell me it's 9?
9 liters. Yeah, I said. And then towing, he gets like 11. Yeah. He deleted and checked it, and I think it's 9 or like 8 or something like that. I know, it's crazy.
What?
I know. And then he said when
Okay,
he's
my F-150 loaded, pulling a horse trailer loaded, is like, yeah, it's like 22 liters per 100. Like, it is a gas guzzling machine. My husband went and thought we should get this EcoBoost, whatever. It's got tons of power. Okay, got no problem with power. It'll pull anything. I can go roll around. Abby, it's important.
We don't get this anymore.
Well, listen, it's important because so my car gets 5.8 liters per 100. So the lower that number, because that means for every 100 kilometers I go, now Kylie, you need to learn this. It's important. For every 100 kilometers you go, in an hour, let's talk hours, if you drive an hour on the highway, the least amount of fuel you use is good, right? Because at $1.40 a liter, 22 liters per 100 is like costing me like $30 an hour to drive by truck, pulling a horse trailer, full of horses, like insane, so expensive. Okay, so 5.8 liters per 100 is better than 10 in his F-150, right? Think of what that's costing him versus what it's costing you to drive your car. Okay, this is what we're talking about. Okay, so yes, my husband talked about buying another half-ton pickup to pull my first truck. I'm like, no, I want that Dodge diesel dually 1 ton.
I think it's a long box too. The biggest truck you can get.
Get the biggest one you can get. Okay, here we go. So we are going down 1 liter for every 10 kilometers, or 10 liters per 100. So this is about the fuel economy of Kale's F-150 empty. Okay. I mean, not pulling something. Okay, so what are the units represented? We're using L for liters. Write it down. And kilometers. Right? Liters and kilometers. And I cannot spell liters that way, but I have to now. All right. So the amount of the fuel in the tank is decreasing. And the rate of change of the fuel in the tank is minus, so if it's just talking about the rate, I'm going to say minus 1 liter per 10 kilometers. Or the amount of fuel is decreasing. If they put the word decreasing in there, then I'm just going to put 1 liter per 10 kilometers. Okay. All right. Then it says, this is a fun one. It says determine the equation of the line in the form of n equals md plus b. Huh. Equation of a line, people, what do you need to know? Nope, tell me the two pieces you need to know. M and B. What's your slope? Do you know it?
Oh, yeah.
Yeah, it's negative 1/10. How will we find where it crosses the y-axis?
I didn't want the coordinates.
Yeah, we know it's more than 50. Do you understand that? Because here's 50. It's a little higher than 50. So I know. So how do I do that again? What's my first step? Find slope. What do I do? Plug it in. And then
Yeah, X and Y.
plug in x and y to find b. There's 3 steps to this process, right? So here we go. I'm going to say, okay, n equals m for slope. I know that already. I don't know what d is. That's distance plus b. So the first thing I do is find the slope and plug the slope into my equation. Done. Now the only way I can find the y-intercept is if I have an n and a d. That stands for the numbers of liters and the distance traveled. So pick any point up there. Okay. Instead of x and y, we should probably call it, this is d. This is d and this is n, right? Number of liters and distance. So I have to put the 40 over here. Hey, pay attention. And my d is 120. And I'm gonna go find my y-intercept. Okay. Little bit of work to do. What is negative 1/10 times 120? Quick.
12. Negative 12.
Now, negative 12. Right? That would cancel this and make it a 12. So you have negative 12. So you add 12 to both sides. And b is 52. Did that make sense? Is that working on my little picture? I think we knew it would be slightly more than 50, right? I'd have to shrink this down. It's hard to go back and forth. But yeah, there's 50. Up a little higher is 52. It should make sense. It should work. Okay, so I have everything I need to write my equation of my line. So I say n equals negative 1/10 d plus 52. There it is. It does not tell me to write it in general form, so I will leave it like that. Remember? Plug in the slope, plug in the point. All right. Tyrone is paid a base salary per week plus commission for selling electrical appliances. Go, Tyrone. The Backyardigans. We could sing this song, right? I actually enjoyed the back. I thought Dora was retarded. I mean, I thought it was. It was just so. And where's the map on the map on? I mean, how many times can you sing the same word? Like, this is ridiculous. But I kind of enjoyed the Backyardigans. It was kind of a fun. Yeah. Okay. Pablo. Yeah. Tyrone. Yeah. So fun. Okay. Here we go. Okay, focus. Okay, sign of your maturity is how fast I can make a comment like that, and then how fast you return, Abby. Focus. Tyrone is paid a base salary per week plus commission for selling electrical appliances. Last week, his sales totaled $3,500 and he earned $620. Now, hold on, wait, what? How does his sales and what he earned? You understand how they're different? He's selling appliances, okay? He's, I don't know, vacuum cleaners, whatever they do. They go door to door, they sell you appliances, or maybe he's just in the store and he just, hey, can I help you? You know that person that comes up to you and says, can I help you find something? Okay, lots of times they're working on commission. So while he sells $3,500 in total, Jeffrey, he's earning $620. It says this week he earned $680 for sales of $4,250. So we're supposed to plot those. Okay, ready? We're just going to kind of ballpark it. We're not going to make a scale. We're just going to throw it out there, see what we get. Do you need to move?
No, I shouldn't remember now.
Malachi needs to move.
I think we're both good. I think we're both fine.
Okay,
We just need to-
that's your last chance. So it says sales are $3,500. So I'll just go over here and you earn $620. Okay, so Let's just make that be that. Let's make this be 3,500 on the sales and 620. Okay, just kind of a thrown up point. And then it says the next one, sales were 4,250, so higher. He had more sales, was a little bit higher, not much. So this point is 4,250, and he earned 680. So I just kind of throw those up there. It may not work. That might have been a bad thing, but you'll at least understand a little bit more money earned, sales, a little bit more money earned, right? Okay. It says calculate the slope. So how do you want to start? Quick. Let's go 680 minus 620 divided by 4250 minus 3500. Is that correct? Did I do that right? Yeah. Do I have that right? Did I do that right? 4,250 minus 3,500 is 750. Okay. And then it says we should reduce a little bit. So 6 over 75 would be the quickest to reduce. And then 3 goes into both of those. 2 and 25. So that means I could actually, well, I'll just leave it right there. Can I go down one more time? So for every, like I know that looks kind of silly, but it kind of makes sense in this context. Do you understand? Because it's money, right? So what is the $1 for? Sales or earnings? Nope, that wouldn't make any sense. If you say the $1 is sales and then he earns $12.50 for every $1, that wouldn't make sense. Remember, this is Y's over X's, correct? So our Y value is earnings. This is how much he earns, and this is the sales. So he earns $1 for every $12.50 he sells. Make sense? So understand it before you answer the question. All right, so it says explain what the slope of the graph represents. Here's what we're going to say. For $12.50 in sales, he earns $1. So then it says say that as a percent. Go do that. How are we going to do that? Yeah, do it. I mean, try to tell me what you get. What do you get? 8%?
Yes.
So he is earning 8% commission. You with me? Then it says calculate his weekly base salary. Okay, wait. Tell me about commission again. What does it mean usually when you work on commission? What is a base salary? A fixed amount. For what purpose? Why would you have a fixed amount?
So you don't go broke.
So you don't get what?
Like you don't go broke.
So you don't get broke because what could happen?
Could not sell anything.
What if you're working during the month of January? Everybody spent their money, right? And they're not buying new appliances in January. They just finished Christmas, but you're still working at the appliance store. You not make any money? If all you made was commission, you wouldn't make a dime. If nobody came into your store, it's not your fault. You're not the owner or the promotion, and you're not making the deal on the sales. You're just the person selling the stuff in the store. So they say, okay, what we're going to do to compensate that is we're going to give you a base salary. So no matter what happens, you make a little bit of money. It's not based on what you sell. Do you understand? That's what commission is. How could we find that? Yes, sir?
Times his earnings by 8%.
Okay, times his, say it again one more time.
Like times what he earned by 8%.
I think it'd be better to times what his sales by 8%.
Can you do it the other way too?
No. So let's go times his sales by 8% and tell us how much he made from commission that particular week, and then find out what we're missing. Would that make sense? So here's what we're going to do. We're going to take his, let's go to 3,500. That was his sales for the one time. And we're going to times it by 0.08. Now I know he made $620. That's what it says, right, Joey? $620 right there. So let's see if this makes 620. What is 8% of 3,500? 280. So he only made that week, he made 280 from the commission part. So how could you figure out how much he actually made from the base? Yeah, just go 620. That's how much he actually made. Take away the 280. What do you get? $340. There you go. That's his base pay. Make sense?
That's kind of sad.
Yeah, it's per week.
Oh.
It's per week. So, but yeah, $620 a week isn't great money. I mean, if you worked 5 days that week, you just made over $100 a day. It's not great, but maybe it's a second job or something. Okay. How does the answer relate to the graph? Well, unfortunately, I didn't do a very good graph. What it would look like if I had done a better graph. When this was 0, I would be up at 340. Do you understand that? Does that make sense to you? And then as he made along, this would go up slightly. But his base pay, when he makes no sales, would be at 340. It's the y-intercept. This base right here is the y-intercept. Write that down. That'll be important. That's the starting spot. At when he has made no sales, he still makes $340, and then as he sells things, he gets more money. So on the next question, on the top of the next page, they want us to write the equation. Well, you need to have your slope. Do we have it? Yeah, it's 1 per 1250 or 8%. So on the next page, here we go. You're going to earn 0.08 times your savings, or times the sales, plus the 340 base pay. Does that make sense to you? That equation should make perfect logical sense. 8% of his sales, that's the commission part, and the base pay was 340. Yes, Abby's saying yes. Okay, 2 weeks ago, Tyrone earned $486. He earned it. Is that your E or your S? E. So we're going to put the 486 right in there for my E. And we're going to find out what his sales were for that week.
Why not just subtract his base pay?
And then
Divide it by 0.8.
0.08. That's exactly what we're going to do. We're going to subtract the base pay. Go ahead and do that. Subtract the base pay. So we'll have 6. Right? And now we'll divide that by 0.08. Perfect. What were his sales for that week? Say it louder. 1,825. $1,825. Y'all agree? I have no idea. I didn't do it. Yep, looks good. Okay, one more quick little assignment, and then we get to work on what you're going to do. Any questions so far on what we've done? All right. John is taking part in a long-distance car race. After 3 hours, he traveled 270 kilometers, and after 6 hours, he traveled 630 on a grid. Plot ordered pairs to represent this information. Okay, so I'm going to say this is 1, 2, 3. So come up with a good scale, make it nice. And we're going to go up to 630 kilometers. So maybe I'll go, let me check. Can I go at 50s? Yeah. I can't. Make sure you're going perfectly even as you move up your scale, right? So I'm doing every line is 50. And I'm gonna plot those. So after 3 hours, he had traveled 270. And after 6 hours, he'd gone 630. Okay, find slope. Go, somebody, quickly tell me what to do. Hurry. So what are your y values? 630 minus 270 over, what did you say, Miles? 6 minus 3. You understand? I didn't write the coordinates over there on the points. You could say, okay, this is the point 6 and 630. This might be a better idea. And this is the point 3 and 270. Makes sense how it's gonna work now? Like label the points if you need to. That helps you. Okay, what is that? 60 over 3? Oh no. No. 300. What? Right? 630 to 270 is how far? 330? 360? There. Better? Okay, so finish. So you get 120. 120 what? Kilometers per hour. All right. So just know your units. All right. It's a change in changing distance divided by changing time. That's called the average speed, people. You know that already. That's just putting speed on a chart. That's all it is. So he said, say the average speed of the car from 3 to 6 hours. We would say 120 kilometers per hour. Then it says, okay, let's draw that line actually. Can you get your little ruler and draw the line? Then it says on the grid, plot the point 0, 0, and determine the average speed, or AKA the slope. Find the average speed during the first 3 hours. Is it the same? I don't know. Mine kind of looks like it is the same, but I think maybe it has a little bend in it. Let's go find out. So because at 0, 0, he would not have traveled anywhere, so there'd be no time and no distance traveled, right? So 0, 0 is a legitimate point. So if I went from 270 minus 0 over 3 minus 0, what do I end up with? 90. So it's not quite the same. It's a tiny bit slower. So that's why it's hard to see, but be as accurate as you can. And it says, by looking at the grid without doing any calculations, how can we tell the speed during the first 3 hours was less than the average speed during the next 3 hours? Just by looking at your picture, can you tell? How can you tell? It's just a little less steep, right? It's a little less steep on that first. So we're just going to write that. It's less steep. Okay. I'm done. Nothing new today at all. Just translating what we've already learned and putting it in the context of a question. Okay?